Welcome back to a new video lecture, and here we discuss a new topic, and it is related with the application of kinematic method to frames. The previous lectures we discussed about the application of this kinematic method over the beams. So here we discuss about the frames, how we can apply those kinematic method to these frames. So in the case of frames, there are three mechanisms actually we need to calculate, that is beam mechanism, then sway mechanism, then the combined mechanism. So let us take a figure. A frame is shown here, and here you can observe ABCD, that's a frame, and W1, W2 is acting as vertical, and this W3 is acting in the horizontal. Okay, so first of all we need to analyze about the beam mechanism. So in the case of beam mechanism, if you observe this BC portion, if you clearly observe this BC portion, there will be a load W1 is acting over here and W2 is acting over here. So here you need to calculate for this W1 that is shown here and for this W2 next one. Okay, so the hinges will be formed at this end, and this both the supports, these points is B and C, and the next hinge we consider under the load W1, first one, second one under the load W2, that is shown here. Okay, then regarding this W3 also there will be a beam mechanism will be formed. Okay, then coming to the next one, that is regarding the sway mechanism. So due to this load, that is W3 or the horizontal load, there will be a chance of sway. Okay, this frame will sway in this way. So again there is a happening of this sway mechanism. In this case there is this W1 and W2 has no role. And then coming to the combined mechanism, at that case you can observe that this W3 and W1 and W2, three cases have importance. Okay, so these are the diagrams regarding this sway mechanism and combined mechanism. Then the details regarding this beam mechanism and these sway mechanisms are written here. So here you can observe that this mechanism can takes place only in the member with the loads acting on its span. Okay, and as in the analysis of beams, in a beam mechanism three hinges are necessary, two at the ends and one in the intermediate position. So let us take an example. So this is a beam, and obviously if a load W1 is acting, under that load the plastic hinge will be formed. Okay, so that is mentioned here. And if it's a propped cantilever beam, it is mentioned that at a distance of 0.414 L from the support end the hinge will be forming. And then coming to the sway mechanism, the two hinges at bottom and the two hinges at the top of the column are necessary for this type of collapse. Okay, so in this case both the supports are at these supports, if you observe this, both the supports at A and D are fixed, and so in this case there will be four hinges will be forming. Okay, at this point, at this point, and at this point, at this point. Okay, so then last, combined mechanism. So the collaboration of this both beam and beam mechanism and this sway mechanism will be happened over this combined mechanism. So doing problems you will get more clarity. All other procedures regarding the calculation of collapse load and the plastic moments, we will get lot of values for collapse load if you consider this different mechanisms. And in the case of taking the collapse load, the least value you have to take, and in the case of plastic moment you have to take the maximum value. Okay, you can observe, determine the plastic moment capacity of the section required for the frame shown in the figure. The loads shown are the working loads. The load factor lambda equals 1.75. So first of all you have to calculate the collapse load by multiplying this 1.75 with each loads. It is clearly mentioned that the loads are working loads. So you have to multiply with this load factor and you will get the collapse load value. That is 40 value it is going to be 70 kilonewton, and the 80 it is going to be 140. Then first of all you have to consider the beam mechanism. So if you observe, if you consider this BC portion, so at the both the joints B and C there will be a plastic hinge, and under the load, this load value is 140, there will be a plastic moment will be here. So the procedures are same, external workload equal to internal work done. So MP theta multiplied MP theta plus theta, that is shown here, then again MP theta, then the load 140 acting here. So 140 multiplied by delta, you will get these values is. And if you equate, how you got this 3 theta value? Let us take this value, it is going to be 3 and here also 3. The span distance it is 6. Okay, and this load is acting at the center point. So if you add up those values, 4 MP theta equal to 140 multiplied by 3 theta and MP equal to 105 kilonewton meter. Okay, so that's the case regarding this beam mechanism. And then coming to the sway mechanism, why we are not considering this one, this 70 kilonewton? So if this 70 kilonewton is acting at this point or somewhere, then you need to calculate that also separately. Okay, to the sway mechanism, so here you can observe that at the each supports, that is A, B, C and D, there will be plastic hinge will be formed. So you can directly calculate this internal work done, that is MP theta plus MP theta plus MP theta and again MP theta, which is equal to 70 delta, and you can calculate this delta value considering this triangle. That is, if you consider this as triangle and taking this theta equal to delta by 4, then delta value is going to be 4 theta and MP value is going to be 70 kilonewton meter. Combined mechanism. So in this case, the plastic hinge will be forming at this joint A, then at this joint D, then at this joint C, and under the load W, or under this, in this case 140 kilonewton. So, and at this point, why it is not forming actually? If you observe that if it is 90-degree forming, and if sway occurs or in this combined mechanism occurs, there is no changes. Okay, there is no rotation is going to happen. That's the reason why we are not considering at this joint. So if you write down this MP theta, that is of this A, then MP theta plus theta, that is of this case, then again MP theta plus theta, that is shown here. This is the reason, that's why. Then MP theta of this joint D. Then if you substitute those values, 70 delta 1, that is the horizontal load, then the vertical load, that is 140 delta 2. And if you add up those values, you will finally get MP equals 116.67 kilonewton meter. And finally, in the case of this combined, in these mechanisms, what about the plastic moment? From these three mechanisms, the beam, sway and combined, the first beam mechanism, the value is 105 kilonewton meter, and the sway mechanism 70, and the last one is 116.67. So out of these three, the last value is going to be give the higher value. So the value of this plastic moment for this particular question, it is going to be 116.67 kilonewton meter. So that is the real mechanism, and this value will give the plastic moment capacity value. So I hope the section is clear, and with this we wind up today's section. Thank you.